And in today's video, we are gonna go over the global water cycle. Sorry, something just came up in my email. Hold on, I'm just looking at it real quick. That's interesting. Okay. So we're gonna go over the global water cycle. Okay, so we want to learn the hydrologic cycle. As a closed system, phase change, evaporation, condensate, just like the water cycle. And then the big question we want to answer is how does a molecule of water move from the bottom of the ocean to the top of the mountain? And why is this cycle essential for distributing solar energy across the planet? Also, you're gonna see 600 times 400. I think Jerry included, you gonna see this across the presentation. I don't know why Jerry included this. So I gotta ask him, but I mean, is he trying to hit a clue on like how many subscribers I might get? I mean, I wouldn't be mad at 24,000 subscribers. Wait, 24, 240,000. I don't know how to do math, but okay, so the water cycle is a closed to matter but open to energy, solar radiation, and the amount of water on Earth remains constant. Okay, so the driving force is solar bioenergetics. So the sun powers the water cycle, and solar energy is absorbed and released during the phase changes, redistributing heat globally. So our key concepts are evaporation, which absorbs heat and cools and then converts liquid to gas. And then condensation releases the heat and then converts gas to liquid. And then as you can see, there's a big arrow, there's a big X in the energy. Is Jerry trying to hint something? I don't know. Okay, so reservoirs versus fluxes. So reservoirs stores water this is places where water resides for a period of time, like the ocean. But fluxes are where water flows and moves between reservoirs, like precipitation, surface runoff, or evaporation. And then residence time is how long a molecule stays in a reservoir. My throat kind of hurts because I'm talking a lot. Okay, uh, next, see this again. Okay, we have atmospheric phase changes, condensation, and this is where warm, moist air rises and cools in the atmosphere. When it reaches its dew point, water vapor condenses back into water droplets, and this requires cloud condensation nuclei, with dust or salt particles for droplets to form on. And this is the primary mechanism for cloud formation. So if you ever wondered how clouds are formed, that is how. And then now we're gonna go to transpiration, and this is where water vapor from plant leaves into the atmosphere, and this accounts for a significant portion of atmospheric moisture. And this is driven by cohesion tension theory, as water is pulled up the xylem, and this is linked to photosynthesis as the stomata opens. Next, we're gonna talk about the runoff and infiltration. So precipitation hitting the ground follows two primary pathways depending on soil permeability and saturation. So surface runoff is where water flows across the surface into rivers and lakes, and dominantly in paved areas or saturated soils. But infiltration is the opposite, and that's where the water soaks into the soil to become groundwater, and this is crucial for recharging aquifers. This again, I don't know what he's trying to say, but precipitation and distillation and participation occurs when cloud droplets become too heavy and falls under gravity. And this process is a natural distillation mechanism when water evaporates from salty ocean and leaves behind the solute. And this precipitation is fresh water, and this is how ecosystems are supplied with drinkable water. Next, we have groundwater and aquifers. And this is the largest store of accessible fresh water, which is saturated zones of surface area where all pores are filled with water. Water table is the top surface of a saturated zone, and aquifers are permeable rock layer that can hold and transport water. Next, we're gonna move on to the vital role of glaciers. Hold on. Okay, so glaciers and polar ice are the largest overall stores of fresh water, around 69%. And this acts as a long-time buffer for the water cycle. Oh my god, did I just say water? Ah, it's too late. Okay, so high albedo reflects solar energy and cools the planet. And meltwater provides essential seasonal flow to major river systems during dry seasons. And then melting glaciers contribute significantly to global sea level rise. Okay, so we're looking at the distribution of Earth's water. So as you can see, the ocean accounts for 97.5%, and that's mainly salt water. And there's only 2.5% of that water is actually fresh water. And glaciers account for 70% of our fresh water, and then glacial water is 30%, and then 1% is actually seawater. So the total water is 97.5 saline, and the other is 2.5% fresh water. And fresh water, it has 69% ice glacial water, and 30% of it is groundwater, and 1% of it is, oh, that's surface water. Okay, so we're gonna go over one practice problem really quick. Just don't look at the answer Jerry put in by accident. I don't know why, but okay, so solar energy reaches the ocean surface. A molecule of water absorbs energy and converts to water vapor. When it rises and condenses over a distant city, what is the net result of this energy transfer? Oh, my chair's squeaking. Okay, I'll give you a minute to just think of it. Uh, don't take me. Take me, don't take me to your best Okay, that's way too much time. So I hope you got C, and I don't really want to go over why, because I feel the water cycle is pretty similar. Actually, I will. So the answer is net solar energy is transferred from the ocean, cooling it and releasing it into the distant city's atmosphere. And I don't know, a rule of thumb I always do is that if it's the most complicated answer, and if it looks the most right, just choose it. That's what I do. That's what I usually do on multiple choice. But okay, so switch. If I oh, I'm getting there. Yeah, it's fine. Oh my god. Okay, so the energy drive is solar energy. The water cycle is a closed system, and that's really just the main picture of hydrologic cycle. So just remember, energy redistribution is as crucial as water distribution with the water cycle. And I hope you learned something cool today. Should I tell a story? Let me think. Do I have any stories about the water cycle? I don't know. I feel like my biology teachers really didn't teach about it. Like maybe they said it for one time, but I feel like they didn't. Well, maybe because I didn't pay attention in the class, but I don't know. Uh, it's fine. Okay. So I'll see you in another video. Ah, bye.